We have another practice problem from Let's Review Physics, the Barron's Review. So if we go to page 31 and we read problem 27, it says, starting from rest, object A falls freely for 2 seconds. The object B falls freely for 4 seconds. Compared with object A, object B falls, and we have some choices here. 1/2 as far, 3 times as far, twice as far, 4 times as far. So let's start doing a little bit of thinking on this one. We know it falls twice as long for twice the amount of time, but those first 2 seconds, the distance covered is going to be shorter than the next 2 seconds because it's accelerating. Things are going faster and faster. So, object B shouldn't fall twice as far. We know it's fallen longer. It definitely can't be half as far because it's been falling for a longer time. It can't be twice as far either. It has to be more than twice as far. Okay? Let's do a little bit of math to see if it's 3 times as far or 4 times as far. So, you can start with a little picture to start thinking about this. Let's draw object A. Okay? And we know this fell for time 2 seconds. And let's draw object B. And we know this has fallen for time 4 seconds. Now before we do any math, let's just think about this. We know in the first second, they both fall the same distance. That's sometime in the future. In the second second, because now 2 seconds later it's going faster. I'm not drawing this perfectly, but we know this distance, the second second, has to be farther than the first. And B is also going that same distance. Now, A is done. That was 1 second. And that, from here to here, that whole thing is 2 seconds. B has also traveled 1, 2 seconds, but it's going to travel again. In its third second, it's going to actually travel even farther than the second second. And then the fourth second, we're going to even travel farther than any of the previous seconds. So we have, here's our third second, and our fourth second, 4 seconds total. We've gone pretty far. So we can do a little bit of math to figure this out. By looking at our equations, first we can see from the question, they're asking us about distances. So we have some givens. We have our time. We have acceleration, negative 9.81. And they're asking us about distance. We know that these were dropped from rest, so we have an initial of 0 meters per second, and we want to know our distance. Well, the only equations with distance and acceleration are the fourth formula and fifth formulas. And since we don't have our final velocity, we're going to go with the fourth one. We're going to go with the distance equation. Distance equals the initial, t, plus 1/2 at squared. We plug in some of those givens. We have 0 meters per second. We have a time of 2 seconds. Whoops, seconds. Plus 1/2. Acceleration is negative 9.81 meters per second squared, and 2 seconds squared. Distance equals, this term all goes to 0. We're left with 1/2 times negative 9.81 times 2 squared, which is 4. Okay. Distance equals, I'm going to leave this. I don't want to do some of this work on the calculator. I can leave this as negative 9.81 times 1/2 times 4 is 2. So this is 2 times that negative 9.81. Remember, the negative sign's there because we're falling downward, so this negative distance is actually a displacement, a movement down. Okay, let's do the same thing for block B. I'm going to use the same formula. Distance equals the initial times t plus 1/2 at squared. Plug in our givens. In this case, we have all the same givens, except time is 4 seconds. So initial 0 is meters per second for our initial velocity times 4 seconds plus 1/2 negative 9.81. Now we have 4 seconds squared. So we do some arithmetic. 0 times 4, that term drops out. We have 1/2 times negative 9.81 times 4 squared. 4 times 4 is 16. And we can just have our 16 and we get negative 9.81 times 8. And if we look at our choices, we can see comparing A, it was 2 times that, negative 9.81. B is 8 times that. So this is actually 4 times bigger than A. And back to our choices, compared to object A, object B falls 4 times as far. We just proved that using math. This is 4 times bigger. Our units here would be meters for both of these. And B is 4 times greater than A.